Okay, we're still working on Unit 1, Outcome 5, Homework 5, Solving Quadratic Equations. So this is Part 2 of that lecture. We're still going to be working through quite a few problems. We ended up with our last lecture on working with completing the square, and I'd like you to see an example of how you can solve an equation using completing the square, but I'd also like to point out that you don't have to use completing the square. There are other methods to solve. So let's go ahead and use completing the square on this example. And again, just as a reminder, you don't have to use completing the square. There's other methods that we could use here. So we have x squared plus 4x equals 32. Okay, so as usual, I'd like to graph this first. I just want to know how many solutions I'm going to have. And I'm going to subtract over that 32 to set it equal to 0. So let's go ahead and look at x squared plus 4x minus 32 on our graph. So go ahead and go to y equal. We have x squared, whoops, better clear that, x squared minus 4x, plus 4x. And then the minus sign is at the end here, minus 32. Okay, graph. Again, you might have to readjust your window. There's definitely something strange going on here. Oh, remember on one of our last problems, this went from -1 to 1. So definitely, let's go ahead and adjust our window. Let's go -10 to 10 on the x and the y, so we can get a look to see what's going on here. We might have to readjust again. It's a good place to start, and let's hit graph. Okay, so I see I have my solutions here. I'm going to get just a little bit more of the graph down here because I want my y min in. And if you notice, this is going down pretty low, x squared plus 4x minus 32, so that kind of gives me an indication that it's going pretty low on my graph. It doesn't tell me exactly where, but I'm going to scoot this down to a -40 and see if it will show a little bit more. Well, mine's up in the top right-hand corner by the battery here. It kind of seems to be stuck. Usually this is rotating, telling me that it's working, but this looks a little stuck. So I'm going to pause for a minute and see if I can get this going again. Okay, I got my graph to work. I had to reboot my online calculator here. So this is what my graph looks like, and it's giving me an idea of where my solutions are. It's definitely crossing the x-axis twice. It looks like they're crossing at integers, so I think I already know what the solution is based on that. And again, I can do the table on my calculator to double check, but my solutions look like to me that they should be, here we are at 1, 2, 3, 4. I'm crossing at x equal 4, and 1, 2, 3, 4, 5, 6, 7, 8, -8. So I think these are my solutions, and I can get them directly from graphing and by checking my table. But I'm going to do this example with completing the square so you can see a completing the square problem worked. Now, all the completing square problems that we've looked at have had a leading coefficient of a 1. There's an implied 1 here. And that's one of the criteria that we have to have in place, is the leading coefficient has to be 1 in order for this to work. So let's look at our equation. And again, we're using completing the square. X squared plus 4x plus blank equals 32 plus blank. So what I'm going to do is I'm going to complete the square on the left, and I have to balance the equation. Whatever you do to one side, you have to do to the other. So let's remember that the whole idea of completing the square is to take half this linear term. Well, 4 over 2 is a positive 2. 2 squared is 4, so I'd add the 2 squared to both sides. Now, if I were to FOIL this out, first outside, inside's last, I get x squared plus 4x plus 4. Now on the right-hand side, 2 squared is 4, 32 plus 4 is 36. So now I have this nice little equation, x plus 2 quantities squared equals 36. And now I finish solving it by taking the square root of both sides. So that's another method that we already use, taking the square root of both sides using that square root property. The square root of something squared is just the base back, so I get x plus 2 equals plus or minus, the square root of 36 is 6. So I have two solutions here, negative 2 plus or minus 6. The negative 2 comes from subtracting 2 from both sides. So I get negative 2 minus 6 and then negative 2 plus 6. Here I have negative 8, negative 2 plus 6 is 4. So this matches directly with what we thought our solution should be. So in my math lab it will say something like, what is the solution set? So I'll use their wording. And then they provide the braces for you. They're already there. And then we put our numbers in order from smallest to largest, so negative 8 to 4. And of course they provide the closing solution set as well. So you can go through the completing the square, or you can do the graphing. Sometimes the graphing, however, won't come up with your solution. And it won't come up with your solution because you have a decimal approximation, and my math lab is requiring that you put in exact solutions. Okay, let's go ahead and look at another example where they tell you that you should use completing the square, but I'm going to show you yet another way that we can solve it. You might get the idea of getting you to avoid completing the square, and I'm not. Sometimes it's just one of the most difficult methods. So let's go ahead and solve. So here we will look at 4x squared minus 4x minus 1 equals 0. So if you want to, you could try and factor this. I'm going to graph it, of course, right away because I want to see what my solutions might be, 0, 1, or 2. 4x squared minus 4x minus 1. So hit y equal, and clear. 4x squared minus 4x, and then minus 1. And I want to do a quick graph, top right hand corner. We might have to adjust the window. Okay, I definitely want to adjust the window. I can see that most of the work here is taking place between negative 2 and positive 2. So I'm going to hit window, and I'm going to go negative 2 to 2. And then on my y-axis, I don't need to go clear down to negative 40. It looks like I could just maybe stick around that negative 2 to 2 area. Let's see what that looks like. Oh good, I thought my computer was going to lock up again. So here's a nice little graph, and that tells me, because I'm crossing the x-axis 2 times, that I'll have 2 roots or 2 solutions, 2 zeros, however you want to say it, for this particular equation. So graphing this first gives you some really good help. Now I also see that I'm not crossing at integer values, so I can't use this as, to find my solutions because they're not integer values. I could go on and find decimals though. So here is a root or a 0 or a solution, and here is another one. So this one is between 1 and 2, and this is between negative 1 and 0. So let's go ahead and use the quadratic formula on this one. Now the directions on this from my math lab were actually to use completing the square, but I want to show you how the quadratic formula works just as well. So here's our quadratic formula. Of course, you should have this memorized. And it has A's and B's and C's in it. So we need to figure out where those A's and B's and C's come from. So first of all, we need to make sure that our equation is in standard form. Standard form means it equals 0. So we have 4x squared minus 4x minus 1 equals 0. This already equals 0, so this is in standard form. Standard form is ax squared plus bx plus c equals 0. So in this case, a is 4, b is a negative 4. I need to take the sign with it, and c is negative 1. Take these values and I plug them in. You have to plug them in very carefully into our quadratic formula. And I have x equal negative b plus or minus b squared minus 4ac all over 2a. And of course my square root sign is in here as well. Now the reason I put all these parentheses up is I don't want to drop a negative sign. For instance, this is negative b, but my b is already negative, and a lot of people will forget the 2 negatives. The negative 4 goes here as well, and both the negative and the 4 are being squared. Here's my values for A and C, and here's all over 2A. Now my goal is to simplify this and come up with my solutions. Now minus a negative 4 is a positive 4. Now underneath the radical here, negative 4 times negative 4 is 16. I guess we could simplify this. We don't need to write it out again. Here we have a negative 4 times 4, which is a negative 16. Negative 16 times a negative 1 is a positive 16. All over 2 times 4 is 8. So again, my goal is to simplify this. I'm not quite ready to simplify it. I need to do a little bit more rewriting. So let's go ahead and rewrite this one more step. So our next step for rewriting would be 4 plus or minus 32 all over 8. Now there is a bit of a temptation here to cancel this 4 and 8, and you can't because the 8 also goes into the root 32. So what you need to think about is simplifying first. Now are there any factors of 32 that are perfect squares? And the answer is yes. There's 16 times 2. So we keep simplifying this. 4 plus or minus 4 root 2 all over 8. We can't cancel the 4 and the 8 yet. We have to factor the 4 out. If I factor the 4 out of the numerator, I'm left with 1 plus or minus root 2 all over 8. And now we can finally cancel those. 4 goes into 8 twice. So when we rewrite our solution here, I get x equal 1 minus root 2 over 2 and 1 plus root 2 over 2 for my solutions. Now I can figure out what both of these are as decimal approximations, because remember, up here in my graph, one of my solutions was to be between negative 1 and 0, and the other one was to be between 1 and 2, so I can check those. So let's check 1 minus root 2 over 2. My calculator. So let's do in parentheses 1 minus square root of 2 over 2. Okay, that's between negative 1 and 0, so that's nice. That kind of tells me that I have something in the ballpark of what I was expecting to see. So that's one of my solutions. The other solution is 1 plus root 2 all over 2. And again, from my graph, I expected to see a solution that was between negative 1 and 0, which I have on the left. And I expected to see a solution that was between 1 and 2, and I have that on my right. Now, if I wanted to be sure about these, I could go back to my graph and hit y equal. Here's still my original equation that I'm working with. Hit my graph. And again, I would go second calc. I'm looking for my 0, because that's where it crosses. Left bound, I know from the work I've done, is negative 1. And here it's moved it to negative 1. And my right bound is 0, and if you want to arrow over, you can, or just put in 0. And if you want to take a guess, you can by moving it, or you can just hit enter on your right bound as well. And I get negative 2.071068, or some such, for my left bound, or my left root. And let's see if this matches over here then. And it does, negative 2.7, negative 2.071, etc. So I know that this is the right answer. I can't put in the decimal. I have to put in my radical form, my exact form. Let's go ahead and check my other one on the right. Again, you'd go to second calc. Let's try that again. Second calc, 0 is the option 2. And now it says left bound. Well, I'm up to the left. I want to get a little closer though, just so I can arrow this in. If I wanted to, I could just put in the number 1, because 1 is to the left of where this crosses. Or you can use your arrow over. And then I can also use the right bound. And you can guess right here, or you can move it a little closer if you want and guess. But you can see that I have a value here of 1.207. And let's see how this compares with all my handwork and my decimal approximations of my handwork. Looks like it's the same. So if you notice, this value here matches this value. These are equal, so that tells me this solution is correct. This value matches this value, which tells me this solution is correct. And so my overall solution, 1 minus root 2 all over 2, and 1 plus root 2 all over 2 is correct. So that's using the quadratic formula. Now you might say, well, wait a minute, that's a lot of work. Well, most of the work we did was in checking it, to making sure it was right. And you should take the time to check your work, especially on a quiz or a test. And if you get into the habit of that while you're working on your homework, you're going to get really fast with your calculator, and you won't have to stop and pause and think about what the keys are doing. Now, one thing that we could do is we could solve this by completing the square as well. So let's do the same problem. We already know what the answers are, and let's do this by completing the square. So same problem, completing the square. So we've done this by graphing, we've used the quadratic formula. I guess we only checked it by graphing. And now we'll complete the square. So our original here, if I remember correctly, was 4x squared minus 4x minus 1 equals 0. Okay, so if we start completing the square on this, first of all, I have a little bit of a problem because this leading coefficient is not 1, and I really need it to be a 1 in order for this to work smoothly. So I'm going to do a couple things here. First of all, I'm going to move my constant over here. I'm going to add 1 across to get 1 on the other side, and then I'm also going to factor out a 4. So here I'm left with x squared minus x equals 1 over here. The 4 is not pulled away from the 1. Okay, so let's see what we have going on. Now remember, for completing the square, you take half of the linear term. Well, half of my linear term, there's an implied negative 1. Half of negative 1 would be a negative 1/2. And this value right here, negative 1/2 times negative 1/2 would be a positive 1/4. Okay, so again, if I square negative 1/2, if I take this value and square it, I get 1/4. Now if you look at this, you might say, okay, you added 1/4 to one side, you have to add it to the other. We really didn't add 1/4, we added 4 times 1/4 because of this 4 that's out front. 4 over 4 is 1, 1 plus 1 is 2. So really what I have here now is this nice little quadratic equation that I need to solve. So let's go ahead and get after solving this, and it's my hope that when we're all done, the solution matches with what we got before. I'm going to divide through by 4 to isolate the quadratic. So I have x minus 1/2 quantity squared equals 1/2. Take the square root of both sides using the square root property. The square root of something squared is just the base back. And here I'm left with plus or minus square root of 1/2, which is the square root of 1, which is 1, square root of 2, which is 2. Put 2 in the denominator. We'd add 1/2 to both sides. And have x equal 1/2 plus or minus 1 over the square root of 2. Now if I remember right, this is not what my solution looks like. It's getting close though. So let's go ahead and simplify this by rationalizing the denominator on this second fraction. Now rationalize means to get rid of the radical by multiplying it by itself. So we multiply top and bottom by root 2, and I'd be left with x equal 1/2 plus or minus the square root of 2, and then root 2 times root 2 is 2. And then I can write this as a single fraction, 1 plus root 2 all over 2. Oops, and the plus or minus is in there as well. Now when we have to write our solutions, that's 1 minus root 2 over 2, 1 plus root 2 over 2. And my math lab already provides the curly braces for that. Now let's see if this matches. 1 minus root 2 over 2, 1 plus root 2 over 2. Yep, 1 minus root 2 over 2, 1 plus root 2 over 2. So you can see, and you could go back through and check your answers with graphing and everything, but we've already done that. So you can see the quadratic formula is just as useful as completing the square, and sometimes it's a little less complicated. Now with the quadratic formula, you need to be very, very careful about a few things. First of all, it always has to be set equal to 0, and you have to be very, very careful of your signs. Now, not all the time will you get a quadratic formula, again, that has any solution at all. So we need to always make sure we graph these real quick just to have a good idea of what's going on. So my first thing I will do with all of these problems that I work is to graph them. Because I want to know, is there 0, is there 1, or is there 2 solutions? Okay, so if I'm asked to solve this, the first step I'm going to take is to graph it. Now remember, to graph this, it has to be set equal to 0. So I'd add that 41 across. So I'd have a plus 41. So x squared minus 8x plus 41. Let's go ahead and graph it. Y equal, let's clear what's there. X squared minus 8x plus 41. And let's hit graph. Now remember, this was from when I had this -2 to 2 scale, so it's a good possibility we won't see anything here. So let's go to zoom, and I'm never quite sure which zoom to choose, so I think I'll choose zoom standard this time, and hopefully it'll find my graph for me. Maybe it'll show up on our screen here. Gosh, nothing's showing up. Well, I have this x squared minus 8x plus 41, so it kind of makes me think there's something going on clear up here. So let's go ahead and change our scale. The window will pop open here. And I think my calculator is frozen up again, so let me see if I can shut it down and restart it, so I'll get right back to you. Okay, let's go ahead and change our scale here. Now it's my Y scale that I need to look at. I think my Y max is too small, so I'm going to go clear up here just for 50, just to see what happens, see if something appears. I hope it, oh, there it is. And look at that, it's not crossing the x-axis, so what do I know right now? If it's not crossing the x-axis, there is no solution. So that's good to know. Now, no solution, of course, means no real solution. That tells me I'll have a complex solution. So this does not cross the x-axis. Remember, the 3 dots in the shape of a triangle mean therefore there is no real solution. I'm only looking at complex solutions only. So that means when I get done with this, I'll have something to do with I running around. Okay, so graph x squared minus 8x plus 41. I did that. And from that, I gain the information that I have no real solutions. I only have complex solutions. This is in standard form, ax squared plus bx plus c equals 0. So I could use the quadratic formula here really easily. Now the best thing to do when you're using the quadratic formula is to go ahead and write it down, and then go ahead and populate it with your values for a, b, and c. So a in this case is 1, b is -8, and c is 41. Now we might get some big numbers here, but that's okay. We can work with those because we have our calculator. So this is my -b plus or minus b squared minus 4ac all over 2a. Now this helps me because I'll make sure everything gets put in appropriately, even with positive and negative signs. So -b minus a -b, b squared minus 4ac all over 2a. Let's go ahead and simplify this. Minus a negative is the same as a positive. There's going to be a lot going on under here. -8 times -8 is a positive 64. And here I have 41 times 4. Well, 40 times 4 is 160, so 41 times 4 is 164. and it's going to be a negative value. And then 2 times 1 is 2. Well, something interesting is going on under the radicand here. 64 minus 164 is negative 100. Ah, that's where my complex number comes from. Now, don't be tempted to cancel the 8 and the 2, because the 2 also goes into the square root of a negative 100. I need to simplify that first. The square root of 100 is 10. The square root of a negative 1 is I. I still can't cancel. I need to factor first, so I'll pull out that 2. 4 plus or minus 5i all over 2. Now these cancel. So my solutions then are 4 minus 5i, 4 plus 5i. 2 complex solutions. Now there's really nothing I can do to double check this on my calculator, because on my graph up here, all I know is it didn't cross. It doesn't tell me anything else. So I'm going to have to kind of rely that I did good work here and I double checked my numbers and everything looks good. So we have so many different ways to solve a quadratic equation. The first thing I would do every single time is graph it, and if I can get a root that's a nice little integer out of that, I will. If not, I could use factoring. If it factors easily, I could use the quadratic formula. I could use completing the square. I could use the square root property. But the point is it doesn't matter which method you choose. If my math lab tells you to use a particular method, it doesn't matter. You still get the same answer in the end, so you don't have to use the method they say. Now, sometimes you'll run into things that don't look like quadratic formulas. For instance, there might be some fractions involved, and the denominator will have the variable. So here we might have 3x over x minus 3 plus 9 over x plus 3 equals a negative 42 over x squared minus 9. Okay, so we're going to clear the fraction by multiplying through by the least common denominator. I have to copy down that 2. Okay, so I'm going to multiply through by x plus 3, x minus 3, every single term, and I'll put that as a fraction over 1. And the reason I put it over 1 is so I make sure that when I cancel, I have the right numerator and the right denominator. 9 over x plus 3. And then on the right-hand side, I have x plus 3, x minus 3. And then I also have that negative 42, x plus 3, x minus 3. Now this actually looks worse, but lots cancel. So the x minus 3's, x plus 3's, x plus 3's, and x minus 3's cancel. So what I'm left with then is this 3x times x plus 3 plus 9 times x minus 3 equals negative 42. Now if I wanted to, I could graph this right now, but I think I'll simplify it first by distributing through the 3x, distributing through the 9, and moving the negative 42 across. So I have 3x squared plus 9x minus 27 plus 42. So I'm going to add the 42 across. Whatever you do to one side, you do to the other. So I end up with 3x squared, 9 plus 9 is 18x, negative 27 plus 42 is a negative 15, or sorry, positive 15. 42 minus 27, and this of course equals 0. Now if you notice there's a common coefficient of 3, so if you wanted to you could factor out a 3, but it's really not necessary. Let's go ahead and graph this right away to see if we get a nice integer solution. 3x squared plus 18x plus 15. So clear y equal 3x squared plus 18x plus 15. I want to double check that. 3x squared plus 18x plus 15. Let's go ahead and hit graph. And I can see I'm crossing at negative 1, negative 2, negative 3, I'm crossing at negative 5 and negative 1. So those look like my solutions. And then I should also be able to check this on the table to be sure that they're actual integer values, because maybe they're just crossing, you know, really close but not quite. And I can see here from my table that I'm crossing as well, so let's pop this into our notes. So again, I could solve using the quadratic formula, I could solve by factoring, I could solve by completing the square, but I always like to graph them right away, and then if I get a nice solution out of graphing, there's really no need to go with a lot of other methods. But again, it's totally your preference. Let's pop this graph into our notes as well, and then we can compare those solutions. And of course, this is supposing that you haven't made any mistakes from the start. Now, one quick comment, I would not even have to clear these fractions. I could graph this right away. The only thing I'd have to do is add the 42 over x squared minus 9. I could have graphed this right away, and I would have gotten the same exact solutions. Now, one thing that we need to be careful of is I don't get solutions like a positive 3, which would make this fraction undefined, or a negative 3, which would make it undefined as well. So just as a quick side note, I could have graphed this right away without all this simplification work. And what I would have graphed was 3x over x minus 3 plus 9 over x plus 3. And then I'd have to add that 42 across. So I could have entered this and graphed this right away as well. I've gotten the same graph, same solutions. Now, a couple quick things. Here's negative 5, and here's negative 1. Here's that value for negative 1 then. We know it's not a decimal, something close to negative 1. And here's negative 5. So our solutions then, or our roots, or our zeros, however you want to call them, are negative 5, comma, negative 1, in order from smallest to largest. So there's another example of some of the problems that you might be running across when you're working these. Now there's one other type of question that you'll be looking at too that has a little bit strange coefficients, and I just want to give you a heads up on that one. If you notice, this is a quadratic because I have my squared term, but my linear coefficient being 6, my constant is 4 root 2, the leading coefficient here is a radical as well. Well, this is in standard form, so this is ax squared plus bx plus c. So I can use the quadratic formula on this. So a is the square root of 2, b is 6, and c is 4 root 2. Okay, so this works perfect. So using your quadratic formula, again, you always write out your quadratic formula first, and then you populate it. Negative b plus or minus b squared minus 4ac all over 2a. So my value of b here is 6. A is root 2. C is 4 root 2. And again, a down here is root 2. So I like to set these up with parentheses and then plug everything in. So I have x equal negative 6 plus or minus 36. Now, 4 times 4 is 16. Root 2 times root 2 is 2. So this is 36 minus 32, all over 2 root 2. Simplifying, negative 6 plus or minus 36 minus 32 is 4, all over 2 root 2. X equal negative 6 plus or minus 2, all over 2 root 2. So I have two solutions I need to work with here. Negative 6 minus 2, all over 2 root 2. And negative 6 plus 2 all over 2 root 2. So I have a negative 8 over 2 root 2. And then I also have a negative 6 plus 2 is a negative 4 over 2 root 2. Well, I can cancel here right away. And I have a negative 4 over root 2. And then here, 2 cancels into the 4 twice, drag along the negative. But I'm going to rationalize these, which means you multiply top and bottom by the radical. So I have negative 4 root 2 over 2 and negative 2 root 2 over 2. We're not done yet. The 2's cancel. The 2 cancels into the 4 twice, and I'm left with negative 2 root 2 And here I'm just left with a negative root 2. So my solutions would be negative 2 root 2, my smallest number first, my larger number second. And you can graph this on your calculator and double check with your decimal approximations, but I think you get the general idea. So the upshot here is there's many different ways to solve a quadratic equation. There is graphing, which I think you should graph every quadratic equation first so you can figure out, you know, what do I have here? Do I have one solution? Do I have two solutions or zero solutions? Then you can decide what method you want to use. If graphing solves it with nice integers, you can be done. You can use quadratic formula, you can use the square root property, you can use factoring, you could use completing the square. So no matter what directions my math lab gives you, you choose the method that works best for you, because they won't know what method you use, because you should get the same answer no matter what method you use. So good luck. I hope you use your calculator a lot with this, because it's nice to visualize these solutions. And as usual, if you have any questions or problems, please let me know.